we've been talking about virtualization with Hyper-V, and obviously we've been discussing things about storage and the components. Does anyone remember what the parent partition was? Guys, if you remember, we spoke about the idea of the parent partition. Does anyone remember what the parent partition was? Just as a quick survey around the room about as far as what we talked about last week. I know we mentioned that last week, but obviously let's see if anyone actually can remember what we talked about. Anyone want to have a go at explaining what the parent partition is?
Is that referred to in a server manager, then we create the disk that way? Is that what you're referring to, or am I going completely off topic
Sorry,
here?
say what you said again.
I hope my mic's not driving mad. Is it okay?
Yeah, no, it's fine.
Am I okay? Good. Is it basically setting it up in server manager and then doing the shares? Is that right? Or
no. I think you're talking about something else. But the parent partition. Does anyone remember that term? You remember the term? I mentioned it last week at least. No, give me a thumbs up if you remember me saying something about parent partition.
I need to look through my notes.
At least you got notes. Yeah, Zach, Nick has. It runs the hypervisor, and Reese has got a thumbs up. So Zach, you wanna sort of elaborate a little bit? What does that actually mean?
It's like in charge of all the upper layer stuff, like
yeah.
all the hypervisors, so like all branches off.
No. I'm not saying you're definitely wrong. It's just that
generalized,
you're sort of like not going down the track I wanted you. What about you guys, Nick and Reese? You want to have a go explaining what the parent partition is? Okay, I'm guessing some people are opening up the PowerPoint from last week and having a quick look
just
at it.
setting up my microphone. Sorry. So isn't it in Hyper-V? Doesn't it run like the base thing, and then you make the child partitions under that for the different virtualization machines that you're running? Is that along the right?
Yeah, I don't know, because I'm not fully understanding what you're trying to say. When we're talking about when you talk about child partitions, or what do you mean by that? Yeah, obviously, it's called the parent partition, and obviously, if there's a parent, there's going to be a child, maybe. But let's give you a hint, okay? So remember we said that Hyper-V was a bare metal hypervisor. Okay, that's related to what we're talking about here.
The core operating systems are like ESXi or Hyper-V server, and then basically it's just like a plain based version, and then you have your I'm trying to think of the right words you use here. I'm having a mental blank.
That's all right. Yeah, having a go is the main thing. It's like you're getting it right or wrong is not the big deal here. It's just want to make sure that you guys understand.
And then you got your whatever you run next. So basically, like you got the physical hardware, and you got the hypervisor operating system, and then basically you just program. Well, you then basically put your virtual machines on that layer. Is that right, or am I still going completely wrong?
Not 100%. I think you're explaining what bare metal virtual hypervisor is, but you're not really explaining what the parent partition is. Okay, let me just recap then. Okay, I sort of emphasized that a little bit last week. In the notes, it was just one line. It said something is converted to the parent partition, but I emphasized it a bit, if you remember. So if we think about what a bare metal hypervisor is, like Matthew mentioned, it's basically where the hypervisor is part operating system, part hypervisor, and then virtual machines are created on top of that with its guest operating system. But if you remember from our lab, when we actually created the Hyper-Vs, they already had the 2016 OS on it already, didn't it? So how is that different to us installing VMware Workstation on top of Windows 10? Or even the Hyper-V feature onto Windows 10? Isn't it a similar method? because you got the operating system and then you've installed a hypervisor. So how is that bare metal? Because you've obviously got that operating system sitting in between the hypervisor and the hardware. So that's not bare metal. That's the type 2, the hosted virtualization. So, but Hyper-V is bare metal. All right, so let's explain that a little bit more. So what happens when you add the Hyper-V role is actually you are sneaking or sliding the hypervisor underneath that Windows Server 2016 OS, if you like. You're really converting that existing Windows 2016 operating system into a parent partition, which is effectively a special virtual machine that, like Zach says, runs and controls the Hyper-V computer. Okay, so that's why it is a bare metal virtualization. So let me see if I can have any drawing skills. So if we actually had this was the server 216 OS. This is the hardware. What really is happening is when we're converting it, when we're actually installing the Hyper-V role, is we're actually sliding, if you like, sliding the hypervisor underneath the operating system. So really, what's happening, is that we'll start again. What's happening is you actually get the hypervisor effective like that, and that now becomes the server 2016 OS. That is still the hardware, and this becomes the hypervisor. All right, and this effectively is the parent partition, and that actually becomes a virtual machine. And then obviously in the future, you just have other, you have other virtual machines created at the same level. And basically, and this parent partition becomes a special virtual machine that actually manages the Hyper-V that's underlaying there. Okay, so this is a bare metal hypervisor in the sense that it's actually sitting between, sitting in front of sitting in between the hardware and the virtual machines. So therefore, that's still bare metal. All right, let's keep on going. So let's actually. So does that remind you of? Yeah, does that sound familiar from what I was talking about last week? Yeah. Okay. Good. Hopefully.
Basically, Alex, that's what I was trying to explain. But clearly, my words and my explaining didn't exactly go today, did they?
I'm not sure. I couldn't.
Well, I'm having a grand day,
you
know what I mean.
Yeah, I couldn't get that out of your explanation, so I just had to make sure I explained it again. Okay, so moving on. We're going to talk about obviously some things we should be already familiar with. We're going to create virtual hard disks, virtual machines, and checkpoints. Okay, so out of those three, pretty much two of them already make sense to us because from our dealings with virtualization from when you first started at TAFE. Okay, the thing is checkpoints sounds brand new, but it's not. Okay, so effectively what we're talking about today is virtual hard disks, virtual machines, and snapshots. So checkpoints is just Microsoft way of saying snapshots, really. For all intents and purposes, it's the same thing. All right, so today we're going to create and configure virtual hard disks, create and configure virtual machines, install and import virtual machines, and monitor virtual machine checkpoints and monitor the Hyper-V. So let's get into it. So first of all, there's two generations of virtual machines, okay? So generation 1 and generation 2. And obviously, as the name suggests, generation 2 is newer than generation 1. So if you like, generation 1 probably were what's common in this server 2008. So yes, Matthew, what was your question?
Hi, Alex. Just regarding those two interfaces. So basically,
sorry, what are we talking about? Yeah, so we haven't even started talking about that yet.
I'm clearly not looking at that. That's all right. I'm clearly not focusing as much as I thought I would. But I was going to just, yeah, I'll touch base with RID and SCSI in a second when we're actually after that. Whoops.
Yeah, no worries. So when I've explained it, if there's something doesn't make sense, that's probably the right time to ask about it. Okay?
I'm having a grand one day. It's one of those days, isn't it?
All right. Okay, so we're talking about generation 1 and generation 2. As the name suggests, generation 1 is older than generation 2. Suffice to say, what we're trying to say is that there's some features in generation 2 which are not available in generation 1, and generation 1 were around in the times of server 2008. It's a bit like what we understand in VMware with the hardware compatibility, if you like. Okay, so if you're not sure of what that means, if I just use this as an example with the VMware, I know we're not talking about VMware, we're talking about Hyper-V, but I'm trying to draw similarities from it. So, for example, if we look at this server 2000, this virtual machine, that doesn't matter which one, you can see that is a hardware compatibility of 15.x, which is the latest. And sorry, let's pick an older one. Yeah, let's pick an older one. And oh, sorry, that's new as well. Clone of DC, that's new as well.
You're trying to specify the hard drive type, Alex?
No, I'm not talking about hard drives at all.
Okay, or the you're talking about the generations like UEFI versus.
Yeah, I'm talking about the hardware compatibility, like I said. Okay.
Yeah, gotcha.
All right. So hardware. So you can see that that's a workstation 12.x. Okay, so that's the hardware compatibility of the actual type of the version. So if you like, in this case of VMware, and basically based on those different compatibility. So if I create a new virtual machine, there's some features which are available and some features which are not available. Okay. Yeah, so for example, if we look at VMware Workstation 5 as the hardware compatibility, you can see that those virtual machines are compatible with Fusion and Workstation 15, sorry. And these are some of the limitations. You can see, keep an eye on the processor core and the amount of memory. And if we switch it down to Workstation 12, okay, let's go even down a little bit more. 8. So you can see that some of these limitations, the 64 gigs of memory is still fine, but then it drops down to 8 gigs of 8 processors. And you can see that these functionality are no longer available in this type of virtual machine, even though it is in the current VMware Workstation I've got in front of me. So if I actually look at that and I change up, those limitations, or no this and no that, is not there. But so basically, that's basically just a version of the hypervisor that created it in VMware, and that's similar to the idea of the generation, virtual machine generations in Hyper-V. Okay, so not as many generations, but generation 1 and 2. And let's have a look at this. So virtual hard disk and directly attached disk, or DAS, support 2 storage controllers. So if you don't know what storage controllers, it's how the hard drives are connected to your computer. So for example, most of our computers in front of us would have SATA, okay, serially attached ATA. And obviously, hopefully all you guys have replaced the hard drive, if not in your physical machine, at least in your portable hard drive. And you know the SATA connections, okay? But in the past, there was one called IDE, and that was what you see in a fat ribbon cable, okay? So let me just quickly see if I can show you a picture. So IDE cable. And if so there we go. Oh, you're just showing off there, Eve. You got NVMe. So basically, these were this type. So you can see that that's very old. Okay, I don't think any of you guys would have seen that in a computer in the last 5 years. And some limitations: you had master and slave on each cable, and there's 2 channels, so primary and secondary. So basically, you could have 4 hard drives, okay, on each PC, each motherboard. All right, so that's what, from a point of view of a virtual machine, it means that when you create a virtual machine and you choose IDE, that's only available in generation 1. So what does that mean? It doesn't mean that actually you're going to have IDE hardware. It just means that that's what the virtual machine's operating system will see from a hardware point of view. So that virtual hardware is IDE. So like I said, there's 2 controllers, 2 devices per IDE controller. So there was the primary and secondary, and on each controller there was a primary master and a slave. Okay, and a secondary master, secondary slave. So 4 hard drives. Virtual machines can boot from the IDE virtual hard disk, but you cannot modify the device while the virtual machine is running. SCSI, on the other hand, is back in the day, again, it's a little bit old. And what we know is probably SAS in the modern day. But SCSI stands for Small Computer System Interface. And this is another way of connecting hard drives of the same era, I would say. And you'll see that it uses, again, SCSI. Yeah, fat cables as well. I think it's showing us a whole heap of it, but they're slightly different. Okay, but the modern day, so that was of the same era. Okay, so the SCSI was more suited for server grade machines or computer of the time, whereas IDE is more for the desktop. So SCSI for generation 1 and generation 2 virtual machines, so you could choose either. You can use that in either. So you can see that IDE is no longer supported in the generation 2. And basically with SCSI, you can have 4 controllers and up to 64 devices per controller. Well, I don't know. Go ring up Microsoft. Matthew?
I was going to say, because SCSI and IDE are still very old interfaces, aren't they?
Yeah, absolutely. They're both very old. They're both of the same era. Like I said, the modern day IDE is SATA, and the modern day SCSI is SAS. Okay?
Yeah, I was going to say, because I use SAS in the server I've got, but at the same time as well, the last time I think SCSI was more hot swap sort of thing, that you had your own dedicated 5.25 inch dock that you could just chuck a SCSI drive in, if I remember correctly.
All right, so let's talk about, so only generation 2 could boot from SCSI. So obviously, yeah, if you use SCSI, choose SCSI as the option, you cannot be in generation 1. And one of the benefits is you can modify devices when virtual machine is running, which is similar to what Matthew were trying to allude to with the hot swappable. Okay. So fixed disks and dynamic expanding and differencing disk files. Okay, so we're going to talk about those kind of things. Basically, if we want to compare it to something we understand, it's like when we actually fix this. Obviously, as the name suggests, the size of the virtual hard disk is the size it's basically the size you get, and it doesn't get any. So it's like when we allocate the disk space straight away. Okay, so when we create a virtual machine, if you remember. Whereas dynamically expanding is where we don't allocate the disk space straight away, so therefore we don't use up all the disk space, but it grows as we're putting data onto it. So that's dynamically, means changing. So dynamically expanding, and there's also the differencing disk files. Differencing disk is similar to the idea we have when we create a snapshot, where the actual virtual hard disk is sort of frozen, and then we spawn another virtual hard disk file, and the changes are put in there. So again, going back to my local machine, I just want to quickly show you this. So let's pick out that Windows Server 2016. All right. Well, this is probably not a good one to use. Let's have a look at this. All right. So you notice that we've got a whole heap of VMDK files. Okay, all very similar to this one. Okay, so basically, what's happened here, if I'm guessing, because I don't think I created this one in particular, is that it was a virtual machine that was created. It was snapshot taken. You can see it's very small. Snapshot was taken. Then they installed the operating system. Another snapshot was taken, and they did various things. And as you went along, various snapshots were taken, and basically new disks were spawned. And each disk is a differencing disk of the previous, from the previous to the current, if you like. So what happens when you take a snapshot is that the virtual hard disk is frozen in time, because obviously you need to be able to revert back to that data state of that data, and anything you do, like deletions and additions, are put into a new virtual hard disk, and that is wiped out if you revert back to a snapshot. And that is effectively what a differencing disk is. There's also DAS, or direct attached storage, in this case disks, and they can be local on iSCSI or Fibre Channel SAN. So you notice that the term iSCSI again is important. So that's related to disk SCSI, obviously, and what it means is that so usually SCSI is a local storage. So we can actually mount, what this point is saying is we can actually mount hard drives which are physical hard drives, as hard drives in a virtual machine. So we can basically give access to a virtual machine to a complete physical hard drive. But we can also mount iSCSI or Fibre Channel LUNs in SANs. LUNs, if you remember the term, was logical units. iSCSI and Fibre Channel are two options. There's also Fibre Channel over Ethernet as well. But if you remember, Fibre Channel uses the fiber optics to connect the SAN, interconnect the SANs, whereas iSCSI basically takes that internal hard drive communication method of SCSI and puts it, or wraps it up, or encapsulate it into IP, TCP/IP. So basically, what it's saying is we're able to send SCSI commands from our computer across the IP network to a SAN device and execute those SCSI commands on that SAN device. All right, so like I said, there's different virtual hard disk file extensions. Okay, so in VMware, we all know the VMDK, but in HyperV, it's VHD or VHDX, and VHD are generation 1, whereas VHDX are generation 2. If you look at it, basically VHD, up to 2 terabytes in size, or 2048 gigs. VHDX, 64 terabytes in size. And the VHDX has additional functionality, like an internal log for enhanced resilience, user-defined metadata. They've got large disk sector support and large sector size for improved performance. And this is the default value going forward in generation 2 and generation 2. We can convert between the formats. So let's say you've created one which is the VHD, but you later realize that I want to turn it into a generation 2, so you can actually convert it from that VHD to VHDX. But VHDX is recommended, obviously, because it's in there supporting the generation 2, and obviously generation 2 allows us more functionality. So it's recommended, but only if you don't have older Hyper-Vs in the mix. So for example, if you had a network with Hyper-V servers, but you had some which were 2012, some were 2008, some 2016, and so forth. So if you did find yourself in that situation, you have to find use that type, the version or the generation that is supported by all. Okay, so that means if you do have any Server 2008s, then you will have to use VHDs. Fixed and dynamically expanding. So let's actually talk about that. So like I said, fixed is where you allocate all the storage straight away. So if you create a 20 gig virtual hard disk, it will use 20 gigs on the disk, on the physical disk that it's stored on. So large initial size, and the creation takes time without the Windows overload data transfer. Some benefits is that it minimizes fragmentation. So obviously, if it's all the space is allocated to this virtual hard disk straight away, it's in one contiguous block on your storage. Whereas if you're growing as you're expanding, that might not be in the exact next block on the actual physical hard drive. It might be, wherever there's free space. With the fixed disk, you cannot overcommit. Cannot overcommit. I'll emphasize cannot. Okay, we'll talk about what overcommit means in a second. But it does result in better performance, especially for older Hyper-Vs, and it should be the one you used in production. Okay, so this is not so with the ones that you choose if you're actually doing this in real life, and it's for actual users to access. Whereas dynamically expanding, like I said, it's like not allocating the space straight away. So as a result, you result in a smaller initial size. It's a lot faster to create. So if you remember creating virtual machines yourself, you'll know that. And obviously in our classrooms, in our labs, in our assignments, we always talk about creating that golden master and not allocating disk space straight away, because we want to save the storage on your portable hard drives. So it can cause fragmentation though, because as the virtual machine, virtual disks are growing, but on the physical drive, there's already data next to that hard drive from a block level, then you will have to be written on another block. And that block could be further down the track, so it's not one contiguous section of the disk. You can overcommit. Okay, let's talk about what overcommit means. Basically, if you're not sure how much space you need on your virtual machine, let's say you've got 6 for this subject, okay, and you will create each one from scratch. You don't know how much you're going to use. You've got 256 solid-state portable hard drive, like most of you do. So you might just go, hey, I don't know how much I need. I better be safe than sorry. So I'll give each of my virtual machines 100 gigs. Well, if you got 6 of them, can you actually fit 6 lots of 100 gigs on your portable hard drive if it's only 256? Obviously not. And obviously in that situation, you cannot use fixed size. You cannot use fixed size and allocate each of them 100 gigs each. If you were using fixed size and you had 6, you're probably allocating them each about 40 gigs. More probably if you had nothing else. So you can see how that's already limiting each virtual machine, because you're not exactly sure how much each would use. Whereas if you're using dynamically expanding, you can just allocate 100 gig, 100 gig, 100 gig, because it's not using that initial size. What it's creating is just a tiny little file, and the data gets written on there as it's being used. So initially you might allocate all of your 6 virtual machines 100 gigs, and then you install the operating system, so it grows. And then you might find, hey, that's the SAN, needs a lot more. So it just adds more data to it, and it grows a lot bigger. It could grow to up to 100 gigs, whereas the other 5 might still end up with 20 gigs each. And if you add it together, that's only 200 gigs you actually used. Whereas you were able to be flexible enough to actually allow that one to grow up to 100 gigs because it needed it. It's got comparable performance, so it's not better performance. It's got a similar performance, but it usually means it's less, a little bit less. But this dynamically, it's great for us learning, teaching, testing, development, but it's not great for production. So for dynamically expanding, it would be something we would reserve only for testing and development. So let's talk about differencing this. If you remember, we said that the differencing disk was the differences after you take a snapshot, if you like. All right, so let's see if we can do this screen. Okay, so differencing disk stores the changes from the parent disk. The parent disk should not change. The differencing disk isolates the changes, and you can have multiple differencing disks that uses the same parent, effectively if you had multiple branches of the same snapshot. But it does increase overhead and it lowers the performance, and it can be used for a standardized base image, okay, which should be avoided in production. So that standardized base image, guys, sounds like our idea of the golden master, isn't it? If we have a standardized base image which has a certain type, certain setup, certain configuration, then we can actually clone many other virtual machines. Or it could be a standard base image where we take a snapshot and we do a full clone, and then from here we go on and specialize it like we do with the domain controller and so forth. Okay, but it should be avoided in production. Okay, so they're using this, what's it, the golden master. So let's have a talk about the difference in this. So, okay, so if you look at this, this is the parent disk. Okay, so this is the original hard drive, and you've made changes to it, written files, file A, file B, file D, with the data. So when you create a differencing disk, or effectively when you create a snapshot with our VMware, this becomes read-only, as in this is not changed anymore. So any changes now, like you're adding data, is done to the differencing disk or the new virtual hard disk that's spawned, and this grows. And we could, if we need something that's that was on the original disk, we'd run there to the it's going through the differencing disk. That's because possibly by reading that we could change it. So we modify. What we modify is not modifying the original parent disk, we're modifying the differencing disk. We create new files, and we could also delete files. No big deal. But you notice that this is not changed, but this is the one that's changed, because this is in that snapshot or checkpoint, whereas this is the current live information, if you like. And if we revert it back to a snapshot, this is what's wiped out and back to this. So directly attached storage, or DAS, virtual machines can directly access physical disks, like we mentioned. They could be internal, so just like another hard drive in your computer, physical computer, in the Hyper-V, or they can be a lung, that's the logical unit, which are attached to Hyper-V. If you remember, that could be through iSCSI, Fibre Channel over Ethernet. So the disk must be offline before you can use it. So the thing is, you have a hard drive, only one operating system can be in charge of it. You can only have one boss, if you like. So they need to be offline, so they can't be used by the parent partition, if you like, or they can't be used by another virtual machine, or so forth. So the LUN, the logical unit on iSCSI Fibre Channel SAN, could be on there as well. There's some pass-through disk considerations, so that's for best performance. Pass-through basically means the instructions are passed through from the virtual machine to the physical device to offload the work that's done by the CPU and so forth. So it can be unlimited size, and it's the lowest CPU utilization. But obviously, as you can imagine, there's no such thing as checkpoints or differencing this virtual hard disks. Well, it's a physical disk. Okay, when you take a checkpoint or you snapshot, it's not going to snapshot that physical disk. There's no portability, obviously, because that physical disk is not movable. It's usually plugged into a physical device, so it's not going to go with the virtual machine if that virtual machine is actually transferred to another site, for example. And it's not included in the Hyper-V backup either. So it's some limitations. Why might you want to use this? It might be a data set that is actually attached to a virtual machine, that is actually where the service on the virtual machine is accessing this this information. Virtual hard disk sharing and quality of service. So provides a shared storage for virtual machines. So use the shared SAS. SAS, remember, is that serially attached SCSI. Disk by virtual machines. Virtual hard disk must be using a VHDX format. It must be connected to a virtual Z controller and must be stored in a failover cluster. Okay, we'll talk more about what a failover cluster is. But then the failover cluster uses what's called a CSV, cluster shared volume, or a scale-out file server with SMB version 3, which we've mentioned a few times already. There needs to be a separation between the infrastructure and the virtual machines. And there's also this thing called quality of service. Have you heard of that term before, guys? Have you guys heard of the term quality of service before? Yeah, so where have you heard it? In what reference, what context? In what context have you heard that term quality of service? Wi-Fi network, streaming, internet? Yeah, do you guys do Cisco? Yeah, so have you heard of it in reference to Cisco? Yeah, so anyone want to have a go trying to explain what quality of service is in the Cisco context? Load balancing? It's not load balancing per se. Load balancing means that you're balancing spreading the bandwidth or the amount of work across multiple devices, ports, internet connections, etc. It's not so much that. But you're on the right track, as in if you've got limited bandwidth. All right. Yeah, so Nick, you got it. So basically prioritizing traffic over a network like real-time video or voice in a router, in a switch, in every Cisco device, there might be a quality of service. And basically it prizes time-sensitive protocols, such as if you're watching a video or you're listening to an audio recording. Just imagine that if you had a 1 second lag, 1 second lag in a voice recording or a video, would that be annoying? Would that be would that affect your ability to understand the information? Zach says yes. Now let me ask you another question. If your web page, let's say like a page you read information, okay, took an extra second to load, would that really affect your quality of being able to view the information or understanding the information? Exactly. So therefore, some things like the web page with just written content and that kind of stuff is not really affected by a 1 second delay, whereas something that's video or audio can be affected by a 1 second delay. Is this similar to SLAs? SLA is a service level agreement. So a service level agreement is really defining what is covered, what is supported, what is not supported, what performance, what's the uptime, and all those kind of stuff. Yeah. So VoIP, yeah, will be one that's affected. SLA is more. Well, it's got to do with everything. Its uptime is part of it. But let's say someone wanted me to help them fix Mac laptop because they can't get VMware working on Mac laptop. Well, to be honest, I can't help that because I've never in my life used Mac OS. But it would be unfair to ask someone to support an operating system that's outside of the scope of what is supported, right? So that's what is usually defined in SLA. Like for example, at TAFE, they will support, let's say, Windows 10, but you wouldn't expect them to support Microsoft Windows 3.11, would you? Not this time of day. So therefore, if someone has a problem with 3.11, if they've got a service level agreement, the ICT are well within their rights to say, sorry, that's not a supported operating system. We can't help. Whereas from a customer point of view, if the SLA specifies that the backups are restored within a week, and the backups are not restored within a week because you had a disaster, then that's something you can actually go, how come you guys are not holding up your end of the deal type situation. So I think we've drifted off the topic though. So let's get back to what we're talking about. So quality of service, prioritization of traffic in SCO routers or switches. But now we're talking about storage quality of service. Okay, so still quality of service, but now we're talking about access to storage. Okay, not just reading and reading and the bandwidth it takes to read and transfer the files. It's really to do with the IOs. Okay, if you remember when we talked about we talked about solid state hard drives. We talked about how virtualization has a high demand on the IOs, input/output operations per second. So basically, storage quality of service restricts disk throughput and configures a per virtual hard disk and dynamically configurable while virtual machine is running. So basically, we can prioritize some virtual hard disk over others. So therefore, the more important virtual machines get attention more so than others. Okay. Some considerations for virtual hard disk storage. Virtual hard disk consumes a large amount of space. We all know that, and they increase over time. And obviously, we should monitor that. We can use multiple physical disks for better throughput. So obviously, writing a little bit to each disk is a lot faster than writing a big bit to only one disk. We should use redundant SSDs, like we all know, dramatically increases the performance. And obviously, we've been banging on about SMB 3.0 file shares. To be honest, that's really more of a Microsoft thing. If you're talking about other virtualization platforms like vSphere, they don't bang on about SMB3 as much as we are in this subject. They're more concerned with, like, for example, iSCSI and Fibre Channel over Ethernet or Fibre Channel. We should use SANs or storage area networks for storing hard disks. And like I mentioned before, most of your advanced features or the features you like and make life really work really well, live migration, failover clustering, and many others rely on the fact you have what's called shared storage, where the storage is shared between many Hyper-Vs. So these SANs should be specialized, redundant, and fast, and share storage for failover clustering. And we should exclude VHDs from the antivirus scanning of the SAN or whatever, because obviously that's really large, and obviously each virtual machine may have span. All right, let's continue on. So let's talk about memory now. So what are the components of generation 1 virtual machines? Like I mentioned, there's 2 generations. So virtual machines have virtual hardware devices. Only devices that Hyper-V supports can be used. And these virtual hardware can be emulated, available during boot, synthetic, available in supported operating systems. That's the guest operating systems. And SRIOV, single root IO virtualization, which is a feature in the hardware that allows for more efficient use of the hardware by the hypervisor. That's available is supported in supported operating system. Prior to Server 2012 R2, only Generation 1s were available. Generation 2 virtual machines, they have emulated devices removed. They use the UEFI firmware instead of the BIOS, which means it supports secure boot. It can boot SCSI controller. It could boot from PXE, pre-execution environment boot. Can use just a standard network adapter. Supports faster boot and operating system installation. It can run side by side with Generation 1 because sometimes Generation 1 must be used for legacy systems. So when you have older systems. Some of the supported guest operating system includes obviously all your Windows 2012 and newer servers, as well as 64-bit versions of your client OS, Windows 8, and obviously Windows 10. Configuring virtual machine settings. Only limited options are available during the creation of the virtual machines, but there's many more once you've created it and you can open up the properties or settings of it. Configuration options depends on the generation of virtual machines. Some are available obviously more available in generation 2 than generation 1. Most settings can be configured only if they are turned off. Okay, so that's an interesting thing. Some things you can configure or change while the virtual machines are turned on, and other things you can't. But the easiest way I like to think of this is if I think of a real machine. If I think of a real machine, what can I do while the machine's on? Okay, I can change networks, can't I? I can unplug my what's a network cable and plug a different network cable in. So basically, change switches, change networks. So that's what we can do in real machine as well. We can change the virtual network it's on while it's turned on. What can we do on a real machine? Can we add or remove RAM on a real machine while it's on? No. So for the same reasons of that, you cannot do that to the virtual machine either. But you probably, some of you might also realize, hey, on some server grade machines, it supports hot swappable memory. Yeah, and even the Server 2016 supports hot swappable memory. But in order to turn that feature actually on, you have to actually restart the virtual machine or the computer anyway. So just think of it like that. What can you do to a real machine while it's on versus when it's off? It's the same thing in the virtual machine. A few settings are configurable while the virtual machine is running, like connecting to a network adapter to a virtual switch, adding a virtual hard disk controller. So that's an additional hard disk. That's just similar to the idea of hot swappable hard drives. Enable or disabling the integration services. And if you don't know what that is, that's similar to the idea of our VMware tools in the virtual machine. And obviously, we can use the PowerShell commandlets to do a lot of things as well. Dynamic memory. This is interesting. So what does the word dynamic mean, guys? You know, like I find myself that sometimes it doesn't matter what technology is. You look at the words in the name or in the description, and it tells you something. Like if it says dynamic means changing, so it changes. Okay, so therefore, if we're talking about dynamic memory, obviously that's to do with changing memory. We know that RAM is always changing. So what is it changing? What we're talking about is not changing of what's the contents of memory. We're talking about the changing of the amount of memory that a actual virtual machine gets. All right, so how's that? So let's think of it this way. When we create a virtual machine and we define the amount of RAM, we are actually saying this is how much the guest operating system will see from a point of view of how much RAM this computer has. The reality is that this amount of RAM is not actually physical RAM. Okay, if it's not actual physical RAM, what other type of RAM or memory is there? Okay, so if it's virtual RAM, yeah, so virtual memory. Okay, so good. So virtual memory. So basically, from a point of view of a virtual machine, they are getting 8 gigs of RAM. No problems at all. But in reality, behind the scenes, what the hypervisor is giving to the virtual machine is a combination of physical RAM and virtual RAM or virtual memory. And we know that virtual memory is just a section of the hard drive that is actually used to store things that cannot be fit into memory. So what we know is that the RAM is very, very fast, whereas the hard drive is relatively very, very slow. So if you have too much virtual memory, your computer or your virtual machine is going to run very slowly. So what's that got to do with dynamic RAM? So it's more efficient to use more efficient use of available physical memory. Shared resources can be reallocated automatically. That's what it gives us. Demand, available memory, and virtual machine memory settings are affected. So what does that mean? Dynamic memory means that the amount of physical memory can change. So there's what's called a startup RAM. So sometimes when an operating system boots up, it actually needs more RAM than when it's actually running, because it's doing a lot of work and loading things up and things up. Okay, so what we can do is we can define a startup RAM, which is actually higher than the minimal RAM. We can define a minimum RAM, and that's not defining the amount of memory a virtual machine has access to. It's just that this is the minimum we reserve for this virtual machine. And we can also have a maximum RAM. So even if we gave the virtual machines 8 gigs, we could define a maximum RAM of 4 gigs. What that means is that the other 4 gigs will be virtual RAM. So we can define all these things, okay? And basically, what that means is that we could start up with more RAM, get it up and running, and reduce it to what's acceptable. The key thing is of this dynamic memory is to make it more efficient when RAM is not highly available in your Hyper-V, meaning that if it's virtualizing 10 virtual machines, for example, and it's running low of physical memory, it's a method of actually making more efficient. There's also a memory buffer, which is a percentage of extra memory reserved for this virtual machine. And there's also a memory weight, which means, let's say that we had 10 virtual machines running, no problems. But what happens if we turn off 1 or 2 or 3? If we turn them off, suddenly all this RAM is available again to every other virtual machine. So therefore, who gets what? It's not free for all. Like I said, in Hyper-V or virtualization, it's not an egalitarian society. All virtual machines are not equal. And as a result, some virtual machines are higher priority to us than others, more important to us than others. So therefore, the ones which are more important will get higher memory weight, which means they will get first dibs or more dibs of any memory that becomes available. Let's have a look at what's going on here. So this is a graphic representation. This is the amount of memory. This is time. For this virtual machine, you can see the startup RAM is 1 gig, the minimum RAM is 500 megs, and max RAM is 4 gigs. So time equals 0, meaning right at the start, all virtual machines actually has 1 gig, okay, because they're all being turned on, okay. So as a result, we're using 3 gigs of the 8 gigs that's on the Hyper-V, so 37.5% utilization. Okay, 15 minutes later, we know that this virtual machine has stayed at 1 gig, whereas this finance has gone up to 3 gigs, and that's probably because that virtual machine is it's not necessarily more busy, and this engineering has gone up to 2 gigs. At 30 minutes, a new virtual machine started up, and you can see that this one has dropped back to its minimum, 512, because it's not being utilized, and this one's gone to the maximum, which is basically because the demand of this virtual machine's information has gone up, and this has dropped down to 2 gigs. So what this is, hopefully this is what you see is that we're able to start all 4 virtual machines and keep them running, even though we're using up 94% of the memory on the host. And also, even though we might have defined each of these virtual machines with, let's say, 4 gigs of RAM, and they're not always using 4 gigs of physical RAM. And that's how we make life, makes more efficient use of the RAM that's available to the host. Smart paging. So paging is like we talked about virtual memory, and paging. Smart paging is the paging file on Windows is basically it's virtual memory. On a Linux machine, that would be the swap partition, okay, or sometimes referred to as swap. Memory management techniques that uses physical disk resources as temporary memory is paging. Ensures virtual machines can always start. Used during virtual memory restarts only. So this is when the virtual machine needs to restart. If Hyper-V is low on memory, so all of this is only important when Hyper-V or the hypervisor is running out of memory. the virtual machine has more startup memory than the minimum, and memory cannot be reclaimed from other virtual machines. This is the situation. So it temporarily degrades the virtual machine performance by using virtual memory and to actually get it to restart, but it's removed after it restarts and performance returns to normal. So the only reason we're using this is so the virtual machine that needs a restart can restart when there's not enough memory. It's not used when virtual machines are started from the off state, so it's really for the restart. So you wouldn't want like an update that needs a restart to prevent. And if we didn't have this, that virtual machine may not be able to restart. So similar idea. So if we talk about these virtual machines again, similar at this time 15 minutes, and when it's t equals 30 minutes, these two have restarted, leaving only 2 of them up, and they're utilizing the 4 gigs, so no more extra memory. But then this is where they use the smart paging to get them to restart. Integrate services, we mentioned how that was similar to VMware tools, and a lot of things you can take forward, and they are running. So a lot of HyperV services are running on your host, guest virtual machine. So these things include operating system shutdown. So just like on your VMware, you can, instead of actually going to the console and shutting down, you can just click shutdown, it'll shut down properly. It'll send the shutdown signal. Time synchronization, synchronizes with the host. Data exchange, that's that copy and pasting and other things. Shared clipboard. Backups with volume checkpoints, and this heartbeat. Okay, this heartbeat will become very important in the future. But basically, the way I describe it is, if you found someone, a human being, on the footpath, and they're unconscious, what's the first thing you do as a first aid? If you've done any first aid, what's the first thing you do if you find someone unconscious on the street? Yeah, you check if they're alive. And you check they're alive by looking for the pulse. And basically, it's a way of us telling whether another human being is alive or not. The heartbeat is how this virtual machine can send this heartbeat information to the host to tell it, I am alive, I am alive. So therefore, if it's alive, it's fine. But if suddenly it doesn't get these heartbeat signals to the host, then the host can assume it's dead, and it might trigger some sort of failover. So once you have integration services installed, you can see that a lot of these hardware on the virtual machine becomes Microsoft Hyper-V specific hardware. So those specific drivers are installed, which actually makes them perform better on the real hardware. Using a virtual Fibre Channel adapter. So like I said, we can access Fibre Channel SANs from a virtual machine, and Hyper-V has a Fibre Channel HBA, host bus adapter. We can use the virtual SAN manager to configure virtual SAN, and virtual Fibre Channel adapters can map to the physical ones and connect to the virtual SAN. Storage hardware should support the N port ID virtualization. That just makes it more efficient to connect the two. Virtual machines can have 4 virtual Fibre Channel adapters, and what's supported is virtual machine live migration, virtual machine failover, MPIO, multipath IO paths to the SAN. And what's not supported is booting from the SAN, Fibre Channel SAN, or checkpoints on the Fibre Channel SANs, or host-based backups, like we mentioned before, or live migration of the data. All right, let's keep on going. We're a little bit behind, but hopefully we'll get there. This next part is going to be fairly straightforward because we all know how to create virtual machines. So basically, once we define the virtual hardware, we can just install the operating system from a CD-ROM, DVD-ROM, or ISO file. We can also install it from the network. So for those of you who did the SCCM, you know that we did. We can copy a virtual hard disk with an operating system. So that's similar to cloning. And obviously we know about the sysprep, which generalizes. We can also use a differencing virtual hard disk, which basically clones a parent virtual machine or parent virtual hard disk. We can also import. Okay, so you can import virtual machines without first exporting it. Only virtual machine data files are needed. Over 40 different types of issues can be detected, such as missing parent disks. So the import process allows us to creates a copy of the virtual machine configuration file, validates the hardware configuration settings, compiles a list of incompatibilities, and displays the incompatibilities and asks you for new settings, and removes the configuration file copy. You cannot start older save states or checkpoints. We can also go P2V, P2V, physical to virtual, and obviously this is useful when you have physical machines, but you want to turn them into virtual machines. We can also convert disks to virtual hard disks. So with the disk to VHD, creates a virtual hard disk for your physical hard disk, and we can actually do that to convert it. So here's that D2 disk to VHD program, and we can choose which partition or which drive to convert. And just so you know, let's say that the C drive is the drive with the operating system. So obviously, if we convert that to VHD, we can actually just mount it as a hard drive in the virtual machine, and it's just like if you got a physical hard drive and you moved it from one machine to another machine, and if the hardware is supported, then it can actually boot up from it. And basically, I'm going a bit quick here because a lot of this is very similar to the idea in VMware, and also it makes more sense when you actually are using it. So there's a HyperV console. So first thing you'll notice is that you don't have the console straight away. That's a bit of it's a bit of a waste of resources. Okay, so unlike our VMware workstation where you have the console straight away and you can see what's on the screen, in HyperV it's just sitting there, the virtual machine, and running. And in order to actually open up a console, you have to double click on it or right click and connect, and basically that will open up a console, and it's very similar to the idea of the remote desktop. So it uses port 2179, but you can modify that. The connection must be allowed through firewall, and it's installed as part of the HyperV role, or you can install the RSAT, the remote system administration terminal, which is a set of tools that you can install on your desktop machine. Single users can connect to virtual machines using a remote desktop. So HyperV administrators can connect to virtual machines, but you can also restrict access to virtual machines by using the revoke VM connect access commandlets in PowerShell. Enhanced session mode is a remote desktop connection to a virtual machine, so we have to enable that. Virtual machines can be without network connectivity. That means we can connect to that without network connectivity, so we don't have to rely on a remote desktop. Devices can be redirected, similar to what we know. We can redirect, obviously, speakers, printers, USB, and folder redirection, as well as shared clipboard for enhanced copying. The remote desktop services component is used, but you must sign into the virtual machine remote desktop user group membership is required. Enabled at the HyperV virtual machine connection and virtual machine level, so that's something you have to go in and turn on. And the operating system you need within the guest is at least 2012 or Windows 8 or newer. Only available when the virtual machine is running, of course. So let's have a look at the chat. Desktop into it from on any kind. So let me understand your question there, Matthew. your question was you can remote desktop into the virtual machine from any client. Only if the rules allow for it. Obviously, if that client is on the same subnet, then it's just remote desktop and it's allowed through the firewall. Ayrton, you said P2V, physical to virtual. Okay, so that's converting physical disks, physical machines to virtual machines. All right, let's keep on going.
Very.
All right, so let's talk about checkpoints. Again, this is something that's very familiar to you guys because we know as snapshots. So you can even see that this is the various snapshots, and you can see the description describes the reasons what happened. And obviously, it's a graphical representation of how they relate to each other, and you can select any snapshot and revert back to it. The thing with checkpoints is it's not recommended in production because you can create problems in time travel. I think we spoke about how if we reverted a domain controller to a snapshot, if we have many domain controllers, we often get that we lose that trust relationship. I'm sure all of you have experienced that before, where if you actually revert the domain controller or a computer in the domain to a previous snapshot, it cannot log on to the domain anymore because it's lost that trust relationship. Yeah, many times, because basically one of you guys have time traveled. That's one of them. Another one is where you've got multiple domain controllers and one of them's got back in time. So what happens to all the RID pool, which is used to create the SIDs, if you remember? All of those is, if they've already been used, they actually get restored to the state where they haven't been used. All right, so checkpoints are not recommended in production. It's mainly used for testing and development. Checkpoints is a point in time virtual state. You can obviously it's not really ideal for backup, but for us in the teaching world, yes, it's great for our backing up a state or saving a state. And if we mess up, we go back to it. But in real life, in production, it's not for that purpose. It captures everything, basically. Your settings, your data, your configuration. It's used for testing and development, can cause issues, and creates difference in disk, which then decreases performance. Cannot be created. The snapshots not be created to the directly attached storage. All right, let's keep on going. So implementing Hyper-V checkpoints. So when you create a checkpoint, you can, when created, a checkpoint cannot be modified, can only be viewed, applied, exported, renamed, or deleted. So what happens when you create this checkpoint is you pause the virtual machine, you create a differencing disk for each of the virtual hard disks that's using. It creates a copy of the virtual machine configuration, then it resumes the virtual machine memory to disk. And what you end up with is you have an XML file, which is the configuration file. You have a VSV, which is a save state file. You've got a memory contents, which is a bin file. And you got a differencing disk, which is a VHD. And this is some of the things. Settings cannot be modified when the virtual machine is selected. To modify the settings, you do those. So at the file level, basically you take a snap. So you have the original VHD. You take that's fine. You take a snapshot, and that gets frozen. Let's actually do that. So you have the data. You take a snapshot. That gets frozen, so that's not changed anymore. You spawn off another VHD file, a VHD file, and any changes or differences or is done here. You take another snapshot. That in turn becomes frozen, and then you generate another differencing disk or a VHD, and you make alterations there. Oops. But then you have a problem. You want to revert back to this snapshot. So you delete the differences there, and you start again. We could also delete snapshots. If we delete this snapshot, we effectively merge the original parent and this differencing disk, and you make one bigger parent disk. We can export virtual machines and checkpoints. Exporting basically gets it out of your Hyper-V system, allows you to import it into another system. Exporting virtual machine is not required. You can just copy the virtual machine files. That's fine. That we can do that as well. Exporting virtual machines consolidates its files. So if you do have all these differencing disks, when you export it, it consolidates it. So basically, you don't have multiple checkpoints in your exported virtual machine. Exporting a checkpoint exports only a single state. Differencing disks in the checkpoint hierarchy are merged. We can do what's called live export. You can export while the virtual machine is running. So you'll find out that a lot of the thing to do with virtualization is maintaining uptime. We should update integration services after import, and we should discard the memory content because obviously that's of a running state of the computer. Some issues with checkpoints in a distributed environment. Distributed environment is where you have lots of servers doing the same thing. So for example, Active Directory, you could have multiple domain controllers. You can have some serious implications and result in corruption. If there's a vector clock synchronization, obviously if one of them reverts to a snapshot, then it time travels basically. So for example, that will distribute applications depends on this logical clock and Active Directory domain services, DFS replication, SQL replication, and applying checkpoints roll back to that logical clock. Members of the replica set to converge at the same state. So if they're not at the same state, who's right? Cryptography. So if you that's to do with encryption, obviously. And obviously, if you go back in time and you're generating keys, that just means it decreases entropy. Entropy means randomness, chaos, because basically this has happened before. Distributed applications using vector clock algorithms have no awareness that it's running in the virtual environment, will not understand what's going on, and it might break. So let's have a look at this. This is a domain controller. We use that as our easiest example. You have two domain controllers, and basically you have a read pool. So read pool relative ID, 500 to 1000. And basically, that's what you use to create the SID when you create objects in Active Directory. We take a checkpoint. We create users. So the read pool decreases, if you like, or increases to 600 because we've used up 100. And this gets replicated to DC2. No problems. So then we actually go back to a checkpoint. We go back to this checkpoint here. You can see the read pool is back to 500, starting from 500, because it's gone back in time. Now, if we actually create counts from this DC, they will start using we create 150 users. Now we'll start using it from 500 again, and so therefore we're going to get 100 of those users, which are going to have duplicate SIDs with users created previously, which are being replicated here. So when it comes to replicate, oops, problem. Only 50 users are replicated. Others are either in the first or second domain controller. Okay, they're not in both, so you go out of sync. So what we can do now is that from Server 2012 R2 onwards, they have what's called Virtual Machine Generation ID, which is basically a counter. And every time designed to address the issues reverting to the past state, it's a 64-bit integer tied to a virtual machine configuration, and generation ID passed to a virtual machine in the BIOS. So application can compare the current and previous values, and if they are different, then it knows that it's gone back in time. So Hypervisor must support virtual machine generation ID. Operating systems in the virtual machine must be generation ID aware, and therefore if, here it is, the generation counter, it's something that you can see. And if it's different, in that situation where we have the multiple domain controllers, there's the generation ID again, and there's the generation ID change has been detected. And if the generation ID is different in that situation with the domain controllers, what will happen is that that domain controller that has a different generation ID will realize this and say, my AD is rubbish, my read pool is rubbish, I'll delete all of that, and I'll pretend I'm a brand new domain controller, and I'll ask for replication from the other domain controllers, and that addresses that situation. But ideally, snapshots should not be used in production, and that's my personal philosophy as well as many others. So snapshots and checkpoints are very useful, but not great for production environments. Use actual backups. Okay, monitoring. So we can use performance monitoring, and obviously we need to add the counters. We obviously have the task manager that we're familiar with, the resource monitor that we should also be familiar with, and we've got event viewers that we've used and talked about before. There's also this reliability monitor, which provides a historical view of the server's reliability and associated events. You can see this reliability has been going up, and then there's error, so it drops down. And we can use this to see what happened in those historical times. We've spoken about performance monitor before as well. As you know, we've used counters, and there's a few counters that's important for hypervisor itself as well as virtual machines. So for example, for the hypervisor hosts, these are some of the important counters to measure. For virtual machines, these are probably the counters we should be working on, looking at. And as a result, we can then do what's called resource metering. Resource metering, as the name suggests, it's almost like a quotering system for resources. So it tracks resource used by virtual machines or pools of virtual machines, and obviously processor, disk, and network. And this can be used for chargeback, meaning if we're hosting for other companies, then we can actually charge them for what they use. The resource metering follows the virtual machine. Doesn't matter which host it ends up on, it still follows it, and configured by using the Windows PowerShell commandlets. And there's also a graphical reporting tool and a basic reporting in PowerShell. All right, so I went through that last sort of half of the slide a little bit quicker than I normally would, and that's because I think when we started talking about creating, installing, accessing snapshots and all those kind of things, it's somewhat familiar to all of us. So obviously, let me know if you have any questions regarding those information we were just talking about. Because based on our knowledge, working knowledge with VMstation, a lot of that is familiar or should be familiar.